Hello, dear students. Hope you're fine. Today, we're going to talk about Bohr's atomic model, chapter 4, section 1. Let's start. You remember that in chapter 3, section 1, we talked about Dalton's atomic theory, then Thomson atomic theory. After Thomson, Rutherford came and discovered the nucleus. Okay, then today, we're going to talk about Bohr's atomic model, okay? Then in chapter 4, section 2, we're going to talk about quantum model or quantum theory, okay? Let's talk about the Bohr's atomic model. Look, Rutherford was in 1911, but Bohr, after 2 years after Rutherford came and he gave his atomic model. Let's talk about Bohr's atomic model. Bohr gave his atomic model in 1913, 2 years after what? After Rutherford. Okay. Bohr, he did his experiment on hydrogen atom. Basha, he explained the structure of the hydrogen atom. So he proposed that electrons in hydrogen atom have energy levels or orbits. Okay, if you see, this is, imagine here the hydrogen atom. He said, we know that Rutherford said we have the nucleus and electrons, they are spread around the nucleus, right? This is the what? According to this is the structure, this is the atomic model of the Rutherford. But after 2 years after Rutherford, Bohr came, he said, inside of the hydrogen atom, we have what? We have electron orbits, orbit, shell, energy levels. Basha, they're all correct. Okay, he said we have what? We have energy levels. Look at this picture. This is much clearer. This is, imagine, this is the nucleus, and he said around the nucleus there are energy levels. Okay, he found that. And he states that electrons spin around the nucleus only in these orbits. Where do electrons spin around the nucleus? He said only in these orbits. Basha, in these shells. Look, electrons, they spin around the nucleus where? In these orbits. Basha? Okay. He says something else. He said when electrons are farther from the nucleus, they have higher energy than when they are closer to the nucleus. He said when the electrons of hydrogen atom, we know that hydrogen has one electron, but when it's closer to the nucleus, the electron has lower energy than the one that has farther from the nucleus. And here, which one is farther from the nucleus? That one, Basha. This electron, because it's very far from the nucleus, we say it has high energy, Basha. And the one that's closer to the nucleus, he said it has what? It has low energy. Why? Because of the lower attraction to the nucleus. And those they are farther from the nucleus, there is low attraction between the nucleus and what? That electron. So when there is lower attraction, the electron has what? Has high energy. But when the electron is closer to the nucleus, there is high attraction between proton and electron because positive, negative, they attract each other, right? Instead of repelling. Okay, so he said there are orbits inside of the hydrogen atom, and electrons, they spin around the hydrogen atom only in these orbits. And he said that the electrons, they are farther from the nucleus, they have high energy than those they are closer to the nucleus. Okay. Also, The electron orbits or atomic energy levels in Bohr's atomic model can be compared to the rungs of ladder. We know ladder, Pasha. We have these are rungs of ladder. Can you stand between two rungs of ladder? No, you can't stand between two rungs of ladder because you can't stand in midair, right? Okay. In the same way, an electron can be in one orbit or another, but cannot be in between. Okay? Cannot be in between. And these electrons can be here, Masha, on orbits, in orbits, but cannot be here. Masha, cannot be between the orbits. Exactly, they must be in orbits. Okay? Let's continue. Let's talk about absorption and emission. While in a given orbit, the electrons neither gain nor lose energy. Normally, electrons in the orbits of atom, they don't lose, they don't gain energy. But when you add an energy to an atom, the electrons gain that energy. Basha? So energy must be added to an atom in order to move an electron from a lower energy level to high energy level. Okay. So if you add an energy to an atom, imagine this electron, it's in first energy level, E1. We said that electrons, they are farther from the nucleus, they have high energy. And the energy level is called high energy level. Basha? And the one that's closer to the nucleus, the energy level, the orbit, it has what? Lower energy. So we say lower energy level. Basha. Electrons, they don't lose or gain energy, but when you add an energy to an atom, the electrons gain to get that energy. When they get that energy, their energy is going to be increased. So when they gain that energy and their energy gain to be increased, they jump to high energy level. Look, they jump here, it has jumped to E2. Basha? So this process is called what? Absorption. So it's the process of gaining energy by one electron and jumps to high energy level is called what? Absorption. Okay. And what's emission? Emission, when electrons jump to high energy level, when they move to high energy level, they don't stay there. Directly they fall back to what? To lower energy level. So when they fall back to lower energy level, okay, they emit an energy. They photon. They emit a photon or an energy. So this process is called what? Emission. Pasha? Here, E photon, or we can say energy of the photon, we know that light, we can say it's made of photons. Photons, they hold the energy of the light, right? Photons, they are like storage. Okay? Then we can say like that. And also we can say the E photon, energy of the photons, the energy that photons they have hold it. So we want to know how much energy we have added to an electron, how much energy the electron has gained. So equals what? E2, energy of the electron in second energy level, minus energy of the electron in the first energy level, right? So imagine here it's the electron's energy, let's say 2 joule, Basha, just an example. And when it gains an electron, is going to be 3 joule, Basha. Joule is the unit of energy. So now we want to know how much energy it has gained. So we say energy of the electron in E2, it's what? 3 joule. 3 joule minus, it was 2 joule. In what? In E1. So it's going to be what? It's going to equal 3 minus 1, 1 joule. So energy of the photon here is what? It's 1. Means the electron has gained only 1 joule of energy. Okay, that's it. Also, it's same here. Energy of photon, the energy it has going to be released, it has released equals the energy of the electrons in E3 minus energy of the electrons in E1. If here it's 3, let's say, and here is 5, 5 minus 3 equals 2. 2 joule means this is the energy of the photon, the energy that the electron has what? Has released. Okay? Emitted. So, thank you very much. This is the Bohrs atomic model. Thank you very much. See you later.